Welcome back to Summarize Science. Ever wonder how 3D models in video games or movies get their detailed surfaces, like the wood grain on a table or the fabric on a character's clothes? It's done through a process called UV unwrapping, which is a bit like carefully peeling an orange and flattening the peel onto a piece of paper so you can draw on it. But for complex 3D models, this peeling process is incredibly difficult, and traditional methods often shatter the surface into hundreds or even thousands of tiny, illogical pieces. Just look at these examples from popular tools. The surface is fragmented into a chaotic mess of tiny charts, which is a nightmare for artists to work with. This is the problem that a new method called PartUV aims to solve. PartUV is a new, intelligent pipeline for unwrapping 3D meshes, and its results are dramatically different. Instead of thousands of pieces, it generates just a handful of clean, logical charts. So, what's its secret? Unlike traditional methods that only look at raw geometry, PartUV uses a learning-based AI to understand the semantic parts of an object. It essentially learns to see a model not as a meaningless blob of triangles, but as a collection of distinct parts, like a computer mouse's buttons and body. It then uses this high-level understanding to make smarter cuts along the boundaries of these parts. The results in their experiments speak for themselves. Across 4 different datasets, including complex AI-generated models, PartUV consistently produced a tiny fraction of the charts compared to the baselines. For example, on one dataset, it averaged just 43 charts, while a standard tool produced over 1,300. And it does this while maintaining low distortion and running at a comparable speed. But what does this mean in the real world? Well, having fewer, part-aligned charts makes life tremendously easier for 3D artists. Look at this example of trying to place a logo on a TV screen. With the fragmented baseline maps, it's a messy, impossible task, but with PartUV's clean map, it's simple and precise. This also means fewer visual glitches, known as artifacts, when you apply tiling patterns or textures to a model. The part-based approach also enables cool new applications, like automatically packing the textures for different parts onto separate maps, helping to keep complex projects organized. It even allows for adaptive control, letting the user decide the trade-off between the number of charts and the amount of distortion. So, to recap, the researchers behind PartUV have created a smarter way to flatten 3D models for texturing. By integrating an AI that understands the semantic parts of an object, their method creates far fewer, more logical, and artist-friendly UV layouts. This not only speeds up the 3D artwork flow but also improves the final visual quality. This kind of intelligent, context-aware approach could become the new standard in 3D content creation tools, making the process of building virtual worlds more efficient and intuitive than ever before. Thanks for watching Summarize Science.